Welcome to our video series, Easy Experiments to Understand a Complicated Earth. Hello everyone, I hope you're all having a nice day. My name is Lorena and it's a pleasure to be here, helping you to understand this complicated Earth with this simple experiment entitled Newton's Color Disk. I chose this experiment because I really like art, and today we're going to work with a lot of colors that are seen in artworks. Here I have a normal white sheet of paper. Or is it really white? Would you believe me if I tell you that here are a lot of colors, like green, yellow, purple, etc.? Well, that's something we're going to discuss today. So we're gonna start by drawing two circles in the sheet of paper. And then we're going to divide each circle into 7 even spaces. Now that we have both circles divided, we are going to start coloring. And we're going to start with orange. It's important that you follow this same order. After orange, we are going to use red. Then purple. After purple, indigo. Afterwards, blue. Then green. And last but not least, yellow. After your circle looks like this, you can cut it out. You will get something like this. Then repeat the whole process with the second circle. Now we have both circles. And now cut a third circle of the same size out of the cardboard. I already have my circle cut. And apply glue to the back of the circles, of the color circles. And paste it on the cardboard. You will get something like this. Now, with your pen or pencil, poke two holes near the center of the circle, like this. There is one hole. and the other hole. We have 2 holes. Now we're going to use the thread and let it pass through both holes. Here it already passed through one hole, and the other end we're going to pass it through the other hole. Now we are going to tie both ends together, just like this. And here comes the last step. What we are gonna do is that we're going to spin several times this circle, and then we're going to release pressure to see the visual effect. We release pressure and then we hold. The faster it spins, the wider you are gonna see it. So make sure you spin it several times. Awesome, right? But what happened here? When the disk is rotating, the colors fade to white. This means that white is a combination of the 7 different colors found in a rainbow. This is due to the phenomenon called persistence of vision, which is created because the brain interprets multiple still images as one. This property is based on the principles of dispersion of light. An example of dispersion of light in nature is the rainbow, since water drops act like a prism in which white light enters and splits into its constituents. This color disk works the other way around. We have these 7 colors that end up looking like one. The one that discovered this was Isaac Newton in 1666, when he set up a prism near his window and projected a beautiful spectrum onto a wall. Newton thought that if all the colors coming out of the prism were contained in the white beam, he could combine them again and produce white light. To prove this, he placed an inverted glass prism in front of the multicolor beam, and the colored band, when combined again, produced a white light. This second part of the experiment is what motivated Newton's color disk. You can now understand why I told you at the beginning that the white sheet of paper had all the colors in it. Being aware of how colors work, I bet you will see everything in a different light, right? Now that you know all this information, try to answer these questions. If white reflects all the colors, then what happens with black? And why can we identify different colors when it is dark? Go check the following sites to find out if you answered correctly.